The Lagrange relation between divided interpolation and the divide formula x0, x1, x2, and the function of x f of x is placed in the point x1 minus x0, x2 minus x1, xn minus xn minus h. So both the formula f of x f of x not x1, therefore f of x1 minus f of x0 by x1 minus x0. So this is the treating as delta f of x0 by h is equal to 1 by h delta f x0 we are taking here. So similarly we are taking f of x0 x1 x2 f of x2 minus f of x0 x1 by x2 minus x0 1 by 2h delta f of x1 by h minus delta f of x0 by h. So both the values are taking here 1 by 2h square delta square f of x0 is equal to, that is a simplification I am doing here. The simplification I'm doing here 1 by 2, 1 by x square 2 factorial delta square f of x naught. So in general, we are taking f of x naught, x1, x2, and so on, xn 1 by x power n in factorial delta power n f of x naught. If the tabulated function we are taking is a polynomial, degree n delta n f of x naught is constant, and hence the nth divided difference of a polynomial, the nth degree are constants. Construct the Construct the divided difference table for the following given the data we are taking here. 0, 1, 2, 4, 5, 6, 1, 4, 15, 5, 6, 19 we are taking here. 0, 1, 2, 4, 5, 6, 0, 1, 2, 4, 5, 6. So this is x is equal to 0, x1 is equal to 1, x2 is equal to 2, x3 is equal to 4, x4 is equal to 5, x5 is equal to 6. So what is the f of x value is 1, f of x2 is 4, f of x3 15, f of x4 3, 5, 4, 6, 5, 19. So therefore, I am taking the values here. The divided difference labeled to the given data is the shows the follows here. So 0, 1, 2, 4, 5. What is the x values is given, the x f of x values is given here. This is 0, 1, 2, this is 4, this is 5. See here, I am taking this is 1, 14, 15. I'm giving the spotlight here. 5, 6 here, 19. So these values, what I'm taking is the 14 to 1. So between these values, 14 minus 14 to 1, I'm taking here. Say here, 14 minus 1 by 1 minus 0, 13. 15 minus 14 by 2 minus 1, 1. So as per that value, I'm taking here. So also that one, 6 minus 5 by 5 minus 4. 19 minus 6 by 6 minus 5. These are values I'm taking here. 13, 1. 1, 13. These are values. I'm importing the values x0, x1, x1, x2, x2, x3, x3, x4, x4, x5. Then I'm taking x0, x1, x2. That is 1 minus 13 by 1 minus 13 by 2 minus 0. These are two. These are three values I'm taking here. Then again x1, x2, x3, x4, x2, x3, x4, x5. The values I'm taking here 0 minus 0 by 0 minus 1. So 0 minus 0 value I'm taking here. This value I'm ignoring 0 minus 0 by 6 minus 0. So that's the values of the fundamental values. So I'm taking here. So find the fourth order differences. Find the fourth order divided difference ABCD of f of x 1 by x, whose arguments are ABCD in this order. So H ABCD we are taking here. Therefore, f of x is equal to 1 by x we are taking here. So that means f of a is equal to 1 by a, f of b is equal to 1 by b, f of c is equal to 1 by c, f of c d is equal to 1 by d. So therefore, f of ab, and f of ab means f of b minus f of a by b minus a. So where we are taking here, so b and 1 by b minus a is equal to b minus a minus b is equal to a into b minus a. So this is a simplification. A by b comes to here. This is comes to the denominator part. This is numerator. AB into B minus A, that we can write here 1 by minus 1 by AB. Minus 1 by AB we can write here after the simplification. Why? Because this is the minus I will take here. So this is A minus B get cancelled. That's why. So we can write here 1 minus AB we can write here. f of ABC, f of BC minus f of AB by C minus A minus 1 by BC plus 1 by AB, same again the same. So f of A, f of AB, f of B by f of B minus f of A, that is the first condition. ABC three conditions. Three conditions we are taking here. F of BC minus f of BBC minus A minus 1 by BC plus 1 by ABC minus A plus C, that's simplifying here. So of ABC by C minus A, that is 1 by ABC. We are taking f of ABCD, f of BCD minus f of ABC by D minus A. F of BCD minus 1 by ABCD minus A minus the ABCD D minus A minus 1 by ABCD. This one I'm taking here. Check your progress I'm taking here also. This is a problem of 1 2 1 2 4 1 2 4 5, that is one. Newton divided difference interpolation formula for a data with unequal intervals. Let f of x naught, f of x1, f of x2, f of xn, so on, f of xn with the values of the function y is equal to f of x corresponding to the values or arguments x0, x1, x2, x3, and so on, xn, where x0, x1, x2, x3, x4, and so on, xn we are taking here. We are taking. So, but then by the definition of the divided intervals, we have x comma x naught, f of x minus f of x naught by x minus x naught. Therefore, f of x is equal to f of x naught plus x minus x naught. And what we are taking here, f of x naught plus multiplication x minus x naught will be f of x minus x naught. So if x naught comma x1. So the simplification of very easy here. F of x naught x1, f of x naught. అంటే తీసేస్తున్నాము ఫస్ట్ x naught x1 తర్వాత x minus x naught, and this is x minus x naught minus x minus x1. They are writing these values here. So therefore f of x comma x naught, f of x naught comma x1 plus x minus x1, f of x comma x naught comma x1, substituting 2. So f of x is equal to x naught plus x minus x naught, f of x naught x1, x minus x naught x minus x1, therefore f of x naught x1. So therefore f of x naught x1 x2, therefore f of x naught x1 minus f of x naught x1 x2 by x minus x2 we are taking here. So therefore f of x naught x1, therefore f of x naught x1 x2 plus x minus x2, therefore f of x naught x naught x1 x2. Substituting these values we can get here. F of x is equal to f of x naught plus x minus x naught. So multiplying here f of x naught x1, x minus x naught x minus x1, therefore f of x naught x1 x2 plus x minus x naught x minus x1 x minus x2, therefore f of x naught x1 x2. By continuing this process up to n plus 1, the order difference we get here. F of x is equal to f of x naught plus f of x naught. This is the one f of x naught x1, f of x naught minus x naught x minus 1. Therefore, three values here. F of x naught x2, f of x naught x1 x2. So therefore, x minus x naught x minus x1, and so on, x minus xn minus 1. So that is f of x naught x1 x2 x3 x4, and so on up to the nth condition we are taking. This formula can be written as this is known as Newton divided interpolation formula, Newton general interpolation formula with divided differences. We now require to polynomial phi of x is most n such that phi of x of h k is equal to 0 1 to n. Therefore, phi of x is equal to what we are taking f of x naught x minus x naught, f of x naught x1 plus x minus x naught x minus x1. Therefore, f of x naught x1 x2 and so on plus x minus x naught x minus x1 x minus x2, so on x minus xn minus 1. Therefore, f of x naught x1 x2 so on xn we are taking it, which is a polynomial degree at most 0 less than or equal to k less than or equal to n. We are taking here phi of x xk f of x naught k xk minus x naught f of x naught x1 xk minus x naught xk minus x1 that is f of x naught x1 x2. There is xk minus x naught xk minus x1, xk minus xk minus 1 f of x naught x1 and so on xk, that is f of xk. For all the higher order terms in the factor we are taking here, xk minus xk, hence f of xk is equal to 0, 1, 2, n. So f of x is equal to phi of x. The r is the reminder we are taking an rn plus 1x, where rn plus 1 is the reminder error term. After n plus 1 terms, rn plus 1 x, x minus x naught, x minus x1, x minus xn, x0, x0, x1, x2, x3, and so on, xn. By adopting an argument analogs to the followed in section of unit, we can show that f of x, x0, x1, x2, x3, and so on, xn. F of n plus 1 by zeta by n plus 1 whole factorial we are writing here, where zeta is such that minimum x3, x0, x1, x. So zeta means x0, not 2 is there. Why? Because we are taking the function, we are finding the value 2, so the one value, so we are writing x, x0, x2, and so on, xn, less than zeta, less than max x, x0, x2, so on, xn. Rn plus 1 x minus x0, x minus x1, x minus x2, and so on, x minus xn. So f of n plus f4 n plus 1 zeta by n plus 1 whole factorial. If f of x is a polynomial degree, then Rn plus 1 x is equal to 0, so that f of x is equal to phi of x. If f of x is not polynomial here, if f of x is not a polynomial here, Rn plus 1 x0 is, that is x is equal to x0, x1, x2, x so on, xn. So that phi of x is nth degree polynomial, so phi of x, f of x is for x0, x1. X0, x1, x0, x1, x2, so on, xn. So there is a no standard notation for indicating divided differences of function f of x. X for arguments, the most commonly used notations are nth order divided differences. X0, x1, x2, and so on, delta n of f, delta power n of x0, x1, x2, x3, so on, and delta power n x0, x1, x2, xn delta power n f of x0, x1, x2, x3, xn. However, in this book, we use f of x0, x1, x2, x3, xn for the nth order divided difference of f for the arguments x0, x1, x2, xn to save the v some points f colon. For the first one, first order difference, second order two colons, and the second order differences we are taking here. So, for an example, we are taking here use Newton's divided interpolation formula to estimate log 1.2 given that 1.0 point triple 1.40 point double 365 1.5 0.40 double 5 0.6931 1.0 x naught 1.0 x 1.2 x2 1.5 x3 2.0 0.003365 4.4 0.6931. Newton divided difference interpolation formula is x minus x naught. Therefore, f of x naught come x1 x minus x naught x minus x1 x naught x1 x2 plus x minus x naught, x minus x1, x minus x2, the f of x naught, x1, x2, x3 we are taking here. We construct the divided difference table given the data here. 0003365 4055 0.693y. So we are minusing 0.33650, then 1.4 minus 10. That is the output is 0.8413. 0.4055 minus 0.3365, 1.5, 1.5 minus 1.4, 0.6935 minus 0.4055, 2.0 minus 1.5. So what is the values? What we are accurating second to one, third to second and fourth to third, we are minusing the values. What is the values here? So here the four values here. You have to see 0.6900, 0.413. This is between 1.511. I am writing here the same. This is the values of 0.572, 0.69. This is between 2.0 to 1.4. The values came here. See here, both the values are came here. So again, I am taking here this one 0.30 minus 0.13 plus the highest value. This is 2 minus 1.0, 0.133. Substituting this is called 1.2 and the corresponding values from the table in the given the formula. F of 1.2 0.00, 1.2 minus 1.2 minus 1.0 0.8413, 1.2 minus 1.0, 1.2 minus 1.4 0.03026, 1.2 1.0, 1.2 minus 1.4, 1.2 1.5 0.1113. So this is after the simplification of this one, after 1.2 substitution 0.1817. But the remainder part are in plus 1 x minus x naught, x minus x1, x minus x2, x minus x3, f power 4 of x4 factorial. That is, so therefore x minus x naught, x minus x1, x minus x2, x minus x3, f power of 4x by 4 factorial 1.2 minus 1.0, 1.2 minus 1 point, and all the values I'm substituting here from the point 0.00. By the remainder is the 4 factorial should be cancelled out in the numerator part, only the x4 part will be there. So 4 into 3 into 2 into 1 will be there. So x is equal to 1, the remainder error 0.0024. Second remainder go just 0.005. We can do it here the same. Again, given the following table, that approximate data of f of x by polynomial minus 10367, 3 minus 639, 822, 16, 11. So minus 10367, we are taking the values here. So f of x is equal to 3 minus 639, 822, 16, 11. So Newton divide difference interpolation formula is f of x naught plus x minus x naught f of x naught x1 plus x minus x naught f of x minus x1 f of x naught x1 x2 plus x minus x naught x minus x1 x minus x2 x minus x3 and so on f of x minus x2. We are taking x minus x minus f of x naught x1 x2 x3 we are taking here, that we have to write only x minus x2. F of x naught, x minus x naught, x naught, x1, x minus x naught, x minus x1, f of x naught, x1, x2. So x minus x2, x naught, x1, x1, x2, x3. So we take x minus x naught, x minus x1, x minus x2, x minus 3. So we take x naught, x1, x2, x3, x4. X4 means x4 here, here x4 is there, but we are taking here up to x3 values we are taking here. So what we are doing here, so if x minus x naught, x minus x1, x minus x2, x minus x3, f of x naught, x1, x2, x3, x4. So now we construct the divided difference table given the data -1, 0, 3, 6, 7. So 3 minus 6, 39, 8, 22, 6, 7. So what we are taking here, -6 plus 3, 39 plus 6, 822 minus 39, 6, 16, 11 minus 822. What we are the same in here, 7 minus 6, 6 minus 3, 3 minus 0, 0 plus 1. So these are values, the four values we have cleared here. Then 15, then we are taking a 15 plus 9 by 3 plus 1. Then 261 minus 15 by 3, 6 minus 0. Then immediate 2, 789 minus 2, 7 minus 7 minus 3. So this is the values output the same. Then 41 minus 6, that is 3 minus 41 minus 6 means 6 minus 6 plus 1. Then again 132 minus 41, 7 minus 0 up to 0. These are the values include here. So therefore 13 minus 5 means 7, 7 plus 1. We are taking here the values of this one. Multiplication of these values we are taking here. 3 of x plus 1 minus 9 plus x plus 1 x minus 0 plus into 6 x plus 1 x minus 0 x minus 3 into 5 x plus 1 into x minus 0 x minus 3 x minus 6. So simplifying here x power 4 minus 3 x cube plus 5 x square minus 6. We are output the value we are taken here. So what is the Lagrange's interpolation formula? So we have divided Newton in divided interpolation formula. When the values of the function are given of the non-equispaced points, we shall derive another formula called the Lagrange's interpolation formula, which is applicable irrespective of whether the given functional values are at equally spaced or unequally spaced points. The accuracy of the Lagrange's interpolation formula, the same and the Newton divided interpolation formula. Let we are taking here let of f of x0, x1, x2. Just a minute. So here let f of x0, x1, f of x2, f of x3, and so on, f of xn. The values of the data function y is equal to f of x corresponding to the values or arguments x0, x1, x2, x3, and so on, xn. Up to I is equal to 0, 1, 2, 3, and are not necessarily be equally spaced points. So n plus n plus n values of the function f of x are given here. Corresponding to the n plus values of the independent variable x, we can assume that f of x to be a polynomial in x degree at most n. Let the polynomial is a0 x minus x1, x minus x2, x minus 3, and so on, x minus xn. Let's say when x minus x naught, x minus x2, and so on, x minus xn. Let's a2, x minus x0, x minus x1, and so on, x minus xn. The intercondition taking here a and x minus x naught, x minus x1, x minus x2, and so on, x minus xn. Where a0, a1, a2, and so on, an are constants. Now we have determined n plus 1 constants are a0, a1, a2, and so on, an. To fix the f of x is equal to x0, we get here f of x naught, a naught, x naught minus x1, x naught minus x2, and so on, x naught minus xn. So a naught is equal to f of x naught by x naught minus x1, x naught minus x2, x naught minus x3, that is x naught minus xn we are taking here. Then put x is equal to x1. So we get here f of x1 is equal to a1, x minus x naught, so x1 minus x2, up to the condition x1 minus xn. We are taking here zero condition. We are taking here, therefore x1 minus x naught we are taking here. So therefore a1 f1 x1. So therefore similarly putting x is equal to x2, x3, x4, and so on. And the values are a2 is equal to f of x2, x2 minus x naught, x2 minus x1, and so on, x2 minus xn we are taking here. In the condition f of xn by xn minus x naught, xn minus xn by so on xn minus xn minus. Now substitute values a0, a1, a2, a3. Even in the equation we will be getting here f of x is equal to x minus x1, x minus x2, x minus x3, and so on, x minus xn, x naught minus x1, x naught minus x2, and so on, x naught minus xn into f of x naught. X minus x naught, x minus x naught, x2, and so on, x minus xn by x1 minus x naught, x1 minus x2, and so on, x1 minus xn into f of x1. So on plus x minus x naught, x minus x1, x minus x2, and so on, x minus xn minus 1. Xn minus x naught, xn minus x1, and so on, xn minus xn minus 1 f of xn. This formula is known as the Lagrange's interpolation formula. It can be used in the whether or not arguments x0, x1, x2, xn are equally spaced. We denote here f of x0, f of x1, f of x2, and so on f of xn, y0, y1, y2, y3, y4, and yn. Then the formula 2 takes from the here only x minus x1 by x minus x2, x0, x1, x0, x2, minus x2, x minus xn, x minus x0 minus xn, y naught, x minus x0, x minus x2, and so on, x minus xn. X minus x1, x minus x2, x minus xn. So take here x1 minus x1, x0 minus x2, x0 minus xn into y naught, x minus x0, x minus x2. So we are taking the first condition x minus x2, x minus xn by x1 minus x0, x1 minus x2, so on, xn, x1 minus xn into y1 and so on plus x minus x0, x minus x1 and so on, x minus xn minus 1. Xn minus x0, xn minus x1 and so on, xn minus yn we are taking here. The above formula can also be written in a compact form as summation of k is equal to 0 to infinity phi of x of xk, x minus xk phi dash of xk. Phi of x minus x naught, x minus x1, so of x minus xn, that is pi, pi k to 0 to pi x minus xk. That is the derivation of d by dx of phi of x, x is equal to. This is a Lagrange interpolation formula, simple and easy to remember, but the computation involved in the formula more cumbersome than the Newton divided interference formula. Using Lagrange interpolation formula, find a polynomial with first the data f1 is equal to minus 3, f3 is equal to 3, 0, 4, 30, 6, 130, then to find So using the Lagrange's interpolation formula, find a polynomial which first the data f1 is equal to minus 3, f3 is equal to 0, f4 is equal to 30, s3 is equal to 132. Hence find 5, x0 is equal to 1, x1 is equal to 3, x2 is equal to 4, x3 is equal to 6. So therefore x minus x1, x minus x2, x minus x3. So we are taking the denominator value x minus x0 minus x1, x0 minus x2, x0 minus x3 into f of x0, x minus x0, x minus x2, x minus x3, x1 minus x0, x1 minus x2, x1 minus. అంటే ఫస్ట్ దాంట్లో 0 తీసుకోవట్లేదు, ఇందులో 1 తీసుకోవట్లేదు, 2 తీసుకోవట్లేదు, అట్లా వాల్యూస్ మనం న్యూమరేటర్ పార్ట్ లో ఫస్ట్ దాంట్లో 0 లేదు, ఫస్ట్ దాంట్లో 1 లేదు, సెకండ్ దాంట్లో 2 లేదు, థర్డ్ దాంట్లో 3 లేదు. సో వాట్ ఈస్ ద వాల్యూస్ ఆఫ్ ద taking and applying these values here? X minus 3, x minus 4, x minus 6 by division of 1 minus 3, 1 minus 4, 1 minus 6. Applying to these values and multiplying to this one. So therefore 1 by 30 minus 15x2 plus 405x square minus 138x plus 1900. Therefore 1 by 2 minus x2 plus 27x square minus 92x plus 60. So they require Lagrange's interpolation formula. So we are taking here 1 by 2 of minus 125 plus. So all these values are clubbing. We are applying the phi in place of x. We are Lagrange's interpolation for what they are asked. The phi I am applying here. So that is the 150 by 2, that is 75. The output value here. Then find the interpolation polynomial, Lagrange's formula, Newton divided difference formula. To comment on the conclusion of your option 0, 1, 2, 4, 1, 1, 2, 2, 5. So 1, 2, 2, 4, x0, 1, x0, 0, x1, 1, x2, 2, x3, 4. This is x is f of x0, 1, f of x1, 1, 1, f of x2, 2, f of x3, 5. So these values also are inputting the values in the equation part. X minus x1, x minus x2, x minus x3. So x0 minus x1, x0 minus x2, x0 minus x3, f of x0. X minus x0, x minus x2, x minus x3, x1 minus x0, x1 minus x2, x1 minus x3 into f of x1. All these values I'm substituting here in this equation again. So x minus 1, x minus 2, x minus 4, 0 minus 1, 0 minus 2. It's the same as simplifying applying here. That is 1 by 12 x cube, 3 by 4 x squared minus 2 by 3 x plus 1. The Newton divided interpolation formula for our points and the data is f of x is equal to f of x0, x minus x0, f of x0, x1 plus x minus x0, x minus x1, f of x0, x1, x2 plus x minus x0, x minus x1, f x minus x2, f of x0, x1, x2, x3. So x, so I'm taking here 0, 1, 2, 4. I'm taking here therefore 1, 1, 2, 5. So 1 minus 1, 0, 2 minus 1, the denominator 5 minus 2, 2 minus 1, then so your wrong mistake. This is 4 minus 2. This is wrong. This is wrong. This one 1 minus 1, 2 minus 1, correct. 5 minus 2, correct. Then 1 minus 0, 2 minus 1, and 4 minus 2, correct. 1, 0, 3 by 2. Again we are taking here 1 minus 0. This is in between 2 and 0 here, 1 by 2. This is 1 minus 3 by 2 means 3 by 3 into 1 by 2. 1 by 2 minus 3, that is 6. Okay, the division of 4, 1. So 1 by 2 minus 1 by 6 minus 1 by 2, 6. So 2 minus 6 minus 4 by 24, that is 1 by 12, exactly correct. 4 minus 0, we are applying these values here, substituting the corresponding values from the table of the formula we get here. F of x is equal to 1 plus x minus 0 into 0, x minus 0 into x minus 1 into 1 by 2, x minus 0, x minus 1, x minus 2 into minus. All these values are 0, 0 and minus 1 by 12. These are 0, 1 by 2 and 1 minus 1 by 12. I'm substituting this equation, that is minus 1 by 2, well, x cubed, 3 by 4 x square minus 2 by 3 x plus 1. I'm taking here. Application of Lagrange's formula to obtain partial fractions of a rational function. Lagrange's interpolation formula is given by x minus x1, x minus x2, and so on, x minus xn, x0 minus x1, x0 minus x2, so on, x0 minus xn, the f of x0, x1 minus x0, x minus x0, x minus x2. So same again, that is x0, I'm not taking here, x1, I'm not taking here. So x minus x0, x minus x2, x minus xn by x1 minus x0, x1 minus x2, x1 minus xn into f of x1 and so on, plus x minus x0, x minus x1, and so on, x minus xn minus 1. So xn minus x0, xn minus x1, so on, xn minus xn minus 1 f of xn is connected in with the partial fraction breaking of rational functions, dividing the above equation throughout by x minus x0, x minus x1, x minus x2, x minus xn, where we obtain f of x by x minus x0, f of x minus x1, and so on, x minus xn. So f of x0, x minus x0, x minus x1, x minus x2, and so on, x0 minus xn we are taking here. So therefore f of xn f of x1, x minus x1, x1, x1 minus x0, x1 minus x2, x0, so on, x1 minus xn, and so on, f of xn. So we are the nth condition we are taking here, x minus xn, xn minus x0, and so on, xn minus xn minus 1. So let the given rational fraction be expressed into two partial fraction f of x, and suppose f of x by pi of x, whose phi of x is equal to x minus x0, x minus x1, x minus x2, and so on, x minus xn. And f of x is a polynomial degree less than n. F of x is equal to f of x naught, x minus x naught, phi of x naught, f of x1 by x minus x naught, phi dash of x x1, and so on, plus f of xn, x minus xn, phi dash of xn. So phi dash xi minus x naught, xi minus x1, and so on, xi minus xi minus 1, xi minus xi plus 1, and so on, xi minus xn. So this is the usual from the partial fraction what we have taken, x naught, x1, xn in the denominator, x minus x naught is the first one. Second one is the first derivative x1, x minus x1, f dash, the second derivative x minus x2, f double dash, and x minus x and phi dash x in the derivative we are taking here only. Then use the Lagrange's formula to express x square plus 6x plus 1, x square minus 1, x minus 4, x minus 6 is the sum of partial fractions f of x square plus 6x plus 1, x square minus 1, x minus 4, x minus 6, f of x by pi of x square plus 6x plus 1. So therefore, x square minus 1, x minus 4, x minus 6, x plus 1, x minus 1, x minus 4. So what we are taking in the denominator of values, we are taking x square minus 1, x minus 4, x minus 6. That's where simplification of this value. The partial fractions are decomposition that f of x naught by x minus x naught phi dash of x naught, f of x1, x minus x naught phi dash of x1, f of x2, f of x minus x2 phi dash x2. So therefore, f of x naught, f of minus 1 whole square plus x into minus 1 plus 1, 4, 1 whole square that is 8, 2, 41, 3, 73. All the values I am finding here. So applying the same here, that is 2 by 35 x plus 1, 4 by 15 by x minus 1, 41 by 30 x minus 4, 73 by 70 minus x minus 6. So in this unit, we can learn that the differences between the backward differences formula are useful only when the values are tabular functions. Is spacing of the intervals in, we have learned the Newton divided interpolation formula, Lagrange's interpolation, both which are the application of the data. The values of function are tabulated either it equally spaced or equally spaced points. The Lagrange's formula is derived without use of the time in finite differences, but the quite cumbersome of to work out here, especially when the number of data points is large. We note that the interpolation formula obtained by using Lagrange's divided formula one and the same. Lagrange's interpolation formula is also used split in given rational function into partial fraction. This is the one, and the next unit I am starting with the basic functions here. Inverse interpolation. What is the inverse interpolation formula? Lagrange's method of iteration of successive approximation, method of reversion of series. After studying this unit, you should be able to identify the problem of inverse interpolation, apply the various inverse interpolation method, by namely Lagrange's method, iterative or successive approximation method, method of reversion of series. Find a real root of given algebraic equation by using inverse interpolation. So what is the in this unit, we have interpolation methods, finding the value known data function y is equal to f of x corresponding to specified value of x lies between two tabular values or before beginning or after ending the tabular value. On the other hand, the converse of a forced process is called inverse interpolation. That is the process of estimating the value argument x corresponding to the given functional value y is equal to f of x. When the latter lies between two tabulated values, f of x and f of xj is called inverse interpolation. For some functions like we are taking here, y is equal to sin of x, y is equal to log e x, you do not find any difficulty with the inverse interpolation. In such cases, the required values x can be computed by easily. So when y is equal to sin x, x is equal to sin inverse y is equal to log e x, x greater than 0, x equal to e power y. But a set of tabular values x and y given, the inverse interpolation poses a difficulty. In such cases, we usually seek the help of numerical method. One of the following methods, Lagrange's method, method of iteration, successive approximation, and a reversion of series also we can learn here. So Lagrange's interpolation method. So Lagrange's interpolation formula. Using Lagrange's interpolation formula, what we are doing is when the n plus 1 tabular values xi, y is equal to f of xi, either the equally spaced and unequally spaced, derived Lagrange's interpolation formula is expressed in a Monod function. Next week we can learn this. So see here first Lagrange's formula, how it is came. X minus x1, x minus x2, and so on, x minus xn, x naught minus x1, x naught minus x2, so on, x naught minus xn. Oh, and the condition is y naught we are applying here. X minus x naught, x minus x2. There is no 1 here. There is no 0 here. So on x minus xn into y1. X minus x naught, x minus x1, x minus xn minus 1. Xn minus x naught, xn minus x1, xn minus xn minus yn. Upon interchanging x and y, we can now express xn function as y as x is equal to y minus y1, y minus y2, and so on, y minus yn. By y naught minus y1, y naught minus y2, and so on, y naught minus yn. X naught, y minus y naught, y minus y naught, y2. So same the values we are applying this formula for y minus y naught, y minus yn1, y minus yn minus 1, yn minus y naught, yn minus y minus, so in yn minus yn into x and the values we are taken. This is applying the formula of interpolation formula for tabulation. Any doubts, ask me. Next week we can discuss the interpolation formula problems. Next week is like the Lagrange interpolation formula. That's all. Thank you very much.